Hi. So this is my first time in Chennai, but I'd like to share some of my thoughts on the observability costs. I think in the previous session, sir actually talked to us about the importance of observability and the different facets of observability. But then the next thing that leads to it is cost. Okay, so I'll be talking about it. But first and foremost, okay, who am I? Okay, I am a lot of these jargons, basically. I started my career as a developer, but then eventually moved into DevOps. I also ran my own company, which did DevOps consulting. I also led the observability and reliability at one of the gaming companies, one of the fast-growing gaming companies, and have substantially contributed to the observability space for several years. Currently, I'm working as a developer evangelist or an intrapreneur, all amazing words to have, in Last9. Okay, so this is not showing up well. What is Last9? Okay, it's a hidden thing. Okay, so Last9 is a unified observability platform, and we are based on top of OpenTelemetry. Okay. Okay, and then what is OpenTelemetry? Okay, so what is telemetry in general? So telemetry is basically three pillars, they say: metrics, logs, and traces. Okay. Events is also something which comes under etc. Something that doesn't fall under metrics, logs, and events typically is metrics, logs, and traces comes as events. One question, quick question. From the previous session by Hemant sir, so there was a mention. So can you guess what could this event be? If it's not a metric, logs, and traces, can you just do a guesswork? What could an event be? Or an example, CI/CD events. There was a build that was deployed or released. Or these are some of these things which are not typically telemetry, but you would want to capture them. They could be some of your custom business metrics also, which you would want to send across to an observability platform. So typically, all of this telemetry is a word which you actually capture all this information about how your application, how your systems, and how your business is performing, and take it into one big processing powerhouse, which is like an observability platform. Okay. Now, we talk about telemetry, but what is OpenTelemetry? Okay, so OpenTelemetry is actually a universal standard for observability data. Okay, it's something which has gained a lot of momentum in the recent years. One of the things why it is widely adopted is that it is vendor neutral. Okay, you are not stuck with a specific form of communication or dealing with your telemetry. You have full control over what you're doing with this telemetry data, and it has established some very good protocols. Why this is good here, just a question here. Anybody here who has worked on OpenTelemetry or knows OpenTelemetry? Anybody knows OpenTelemetry here? Okay, there are fewer hands, but this is something you can go back and try to find out what is OpenTelemetry. One thing that you can also do after this session is, based on your tech stack, just Google for how good the OpenTelemetry support is there. For, say, example, you're using Java or you're using Node.js, or are you using Kubernetes? So what is it that is available with OpenTelemetry? It will be a good read for you, so you can try to understand. Okay, now we'll come to, let's talk about money. Few questions here. Anybody here knows exact spends? So basically, anybody here knows your cloud bills or your infra bills? How many of you all know? How much are your core bills? Okay, a lot of people, right? Okay, and how many of you all know your observability costs? Okay, and how many of you all think your observability costs are under control? Okay, nobody? Okay, one person. Okay, we should talk. Okay, typically this is one observability cost crisis. These are some stats. Basically, over the period of long time, there is a lot of observability data which is being collected. Why? Okay, one more thing, I'll just step back. So why is observability important? We have covered that in the previous session. So you want to have most reliable systems, right? So observability is important, okay? Observability leads to a lot of telemetry data, okay, which you are capturing, and then you are querying, okay? That has a cost, okay? And you would want your systems to be reliable. More reliable, let's gather more telemetry data, right? Okay, so what has happened is there is a lot of data that is coming in, and it is leading to a problem which is a cost concern, cost of observability. So one question here. So what do you think should be an ideal cost of your observability? Anybody here would want to answer? What should be the cost of your observability platform? Okay. Yeah, somebody's telling 20%. Yeah, so there's 20%. Yeah, so typically industry average today is somewhere between 10 to 30%. So you are kind of bang on. But can you optimize it? Can you bring it down to less than 10% of your infra cost? So 20% of your infra cost. So example, if you're spending $1 million on your cloud infra, so how much should you spend on your observability? So today almost 20K, 200K would be spent on your observability costs, which would probably be an acceptable range because it's 10 to 30%. But seriously, do you really want to do that? Or should we actually bring it down to 50K? Is it really possible? And at what cost? Okay. So this is something we'll go through in this session. There are some other parameters. When you talk about observability, there are some other hidden costs. It's like the platform fees, any platform, a basic platform fee. There are egress. Okay. So egress is essentially data transfer from your application into an observability platform. There is an engineering time and effort which is spent in maintaining, ensuring that you are observing everything and you're observing it right, and then you're querying correctly. Okay? And then you could have actually used that. There's an opportunity cost. So basically you could have actually used some other tool. Instead of that, you have ended up spending in observability. So these are some other hidden costs. Okay? But I like to quickly touch base on one of the cost paradox here. Okay? So typically we say that, okay, government builds a very good road for you. Does it really reduce the traffic on the road? No. Why? Because more people take their cars out. Okay. Similarly, your bandwidth. So today, over the last so many years, internet has become very cheap. Okay. But what are we doing? Okay, we are now watching Netflix, we're playing games, we are actually using it a lot. So similarly, when the observability cost becomes affordable, what happens? Okay. What happens is that you send a lot of data to observability. So over a period of last 10 years, from observability being a major cost, the cost of observability per unit has reduced, which has led to getting a lot of observability data into your systems. Okay. Now, is that right? Is that wrong? Okay. It's a problem. Okay. So basically, what if you observe too little? You would miss on some critical issues. There would be, at the time of problem errors, you will see that, okay, my observability coverage was poor. I didn't know that something was wrong. I didn't know that system. There could be these problems. If you observe too much, there is a cost problem. Okay. So the real problem is, how do you identify and control what needs to be done? And this is something which we will cover right now in this session. What we require to be able to figure out what to observe is transparency, intelligence, and decisiveness. Okay? So in the next few slides, I'll just take a little bit of a deep dive into few tips on how you could optimize your observability costs by ensuring that you have control over the data that you have. Most of my examples would cover open telemetry, but I've tried to keep it open-ended. You could apply the same thing for some other platforms that you're using. If you're using something which, like if you're building in-house observability, you can actually go ahead with these principles as well. At the end of it, I'll try to do a demo if the demo works today. If the demo gods are okay, so I'll try to do that. So essentially, when observability, so this is what, if you should know what you need to observe. Okay. So let's address one important thing is high cardinality. Okay. How many of you here have heard cardinality first time today in this room? Okay, great. So not too many, but I'll quickly mention when you talk about data. Okay, so observability is a typical data engineering problem. You have lots of data. You have to store it. You have to query it. Okay, now data has typically two different, I'd say, dimensions. One is amount of data that you're sending in, and typically if you have to visualize how many number of columns you have in a data. So in a layman terms. So the data is how much volume of data you're sending and how much are the labels or attributes that you are attaching to a particular data point. So that is called as cardinality. Okay? When you're sending too much data, you are actually sending data with high cardinality into your systems. Okay? Now, this is an example. So consider that you're a SaaS company and you want to monitor your API. Okay, so example, one of the metrics would be the duration, the HTTP request duration. So you decide that I want to capture the endpoint user ID, session ID, request ID, and instance. So these are the things that you would be sending. So in this case, the metric, for a little bit, the metric that we are talking about is HTTP request duration. The others are attributes or labels. Okay. Now all of these attributes and labels will have different values. Okay, and then there will be a duration in milliseconds. When you club this together, you'll get, say, 10 milliseconds, 20 milliseconds, 1 second, whatever is the duration that you would get out of this. Okay, now what happens typically? Okay, when the company is small, this is working fine. Okay, but as your number of users on the systems increases, what happens in here? Anybody would like to take a stab at why would the cost grow if you have something like this that you're monitoring? Any guesses is fine. So what is wrong in this observability metric? Yeah. Correct. Yes, perfect. And why? So he mentioned, for those who couldn't hear, so there is a storage cost, there is a query cost, and there is also a lot of volume that is getting generated. So why is this volume getting generated? Okay. So if you look at this, there are actually 3 different parameters that we are tracking here. User ID. Every user will have a unique ID. More number of users, more number of unique IDs. Okay, your cardinality has increased. Now every user would have different session IDs. These session IDs are also pretty unique. Now you combine user ID with a session ID, it's going to multiply. Okay, same user, 10 times a day they have logged in, it's actually become 10x suddenly. Okay. There is one more metric I'd like to talk about. There is something called as an instance. Would you really require an instance to be tracked for a HTTP request duration? You may not need it. So these are some of the things that you need to take a look at in this terms is, the problem is that I just mentioned there are too many data getting generated because of unique attribute labels that are generated. One of our friends also mentioned, yeah, there is each time series leads to more money to ingest, store, and query. The egress cost, storing cost, as well as the query cost. Okay, and then all of this starts multiplying rapidly. Okay, so what's the solution? How do we solve this? Okay, so this leads to 3 top ways of how you could address this. Okay, I'll go one by one. One is basically smart labeling. Okay, typically there's this concept of bounded and unbounded metrics. You really don't need something like a session ID. Okay, you may not require a request ID. Okay, you may or may not require user ID based on your use case. This is where you have to take. But user ID is bounded, session IDs are unbounded. So first rule is do not use labels which are unbounded. So you can go back, take a look at what are these metrics that are getting generated and see, do you really require those values? Second thing what you could do is do pre-aggregations. So example, if you want to calculate your P95 for a response time, okay? So you want to find the latency or the time taken, the duration for the P95 duration, okay? Typically, you're not going to take it per user ID, okay? You would want to see the endpoint. So I'm just going to go back to this. If you want to find your P95, what are the different labels that you would use here? The endpoint, essentially. You may not require the user ID, right? So what you can do is you can just aggregate it and drop that user ID. Additional thing you could do is you could transform things like in the endpoint, consider you are sending a lot of parameters. You don't need those either. Just drop them. It suddenly brings down your entire cardinality and cost by 20 to 30% down if you do these things right. Any questions so far? Yeah. That's a very good question. Where do we apply this? Okay. So what are the different things? I'll actually answer this. I'll get to this. There is one slide which I'll be talking. So I'll hang on to that. Okay, that's a very good question. Yes. Yeah. This one? Pre-aggregation. Okay. Yes. Yeah. So so this is typically, there are different words for this: streaming aggregation, pre-aggregation. You could also call it recording rules. In Prometheus, it's called as recording rules. Now, there are different words for this. What it does is, given a particular, this is going to help you save your mainly query time performance by doing something beforehand. It's a simple thing. Logic is, you get some of your, like in the morning, you have a lot of work at home. Maybe you'll get some of the things organized or sorted beforehand. Okay, that's what it is. So what do? So example, if you want to, what you would do is, given a data set, you will compute some small, aggregate certain metrics over a period of say 5 minutes, 1 minute, based on your time slicing, and you'll keep them pre-computed and ready. So in your query, when you're going to query it for some complex things, you would have something which is pre-computed already. And the reason I'm calling it as pre-aggregation, or the main difference between a recording rule of Prometheus and a pre-aggregation is, so you do this pre-ingestion times. So you do all of these aggregations before you actually ingest them into your storage. So you have something already ready. Optionally, what you could do is, if you're pre-aggregated, then what you could do is, you don't need certain things at all. Don't store them at all. Drop them completely. Another thing would be like, again, so this, if I'll just focus a little bit, since you've asked this question, there is this thing on drop unwanted labels. Okay, I'll give you an example here. Again with this, okay, consider you're dropping instance from here. Okay, and remember, this is calculating the duration. Okay, you don't really require instance, you just drop it. Okay, but what if you decide to drop user ID? It will affect your duration, right? So user 1 took 1 second, his request took 2 seconds. Now you drop user ID, it will not give you the correct numbers. In that case, you have to do a pre-aggregation. So aggregate between the two, it comes to, say if you say P50 or something, it will be 1.5. This has gone. Okay, so basically that's what the pre-aggregation is. In terms of, you can drop a label, you pre-aggregate. You create something which you might require more frequently, you pre-aggregate it and work with it. Yeah, great. Yeah, basically it's a kind of a recap. Where do you apply this? When you have too many metrics with high cardinality. If there is user specific, I'll just quickly skip through as we've taken a longer time. The other thing that you should apply is sampling. Okay, now this is again a sampling scenario. Okay, anyone here knows what is sampling? How many people? Okay, a lot of people, so that's great. So I'll accelerate a little bit. So basically there is this debate on, should you sample your data or should you send 100% of your traces into an observability platform? So this is a question here. One of the biggest pointers, which again, where do you, if you are sampling say 50% of your requests, so what are the requests that you should sample and which are the requests you should not sample? So essentially, if you are, this is actually giving you, you have typically 99%, 99.9% success, and there are probably 1 or 0.1% failures. You're more interested in looking at the failures, but you're storing 100% of your data. So what should you do in this case? Okay, so the other thing, should you actually drop all that 99.9%? No, you might want to track which were the requests which took a long time. So they're not errored, they're successful, but it has taken longer time. So these are some of the decision-making criteria, which I'll talk a little bit in detail. So you can quickly go through this. This is something which we have typically heard from a lot of customers, that how can you bring down the costs? And if you're asked the question, okay, what is the value add of observing everything? Okay. Okay. So what is the solution to this problem? Is basically you can do tail-based sampling. Okay. Tail-based sampling, I hope you can read. So the first one is telling you that do not sample. So all of this is telling you don't sample anything which has an error. Okay. The second block is telling you that do not sample anything which is taking more than 500 milliseconds. Okay, basically anything which is slower than some X number, do not sample it. We want 100% of that. The second thing is, what it is telling you is, if it's a normal traffic, it's successful 200 request code, and it's a fast request, then you can actually sample it. So take only 1% of that. Okay. And one of the other last factor over there is there are some very important endpoints. Example, your payment endpoint or some checkout endpoint. Okay, you don't want to sample. You want them to get at 100%. You don't want to drop those. Okay, so these are some of the configurations. This is an hotel configuration for sampling. So basically with this, it's just doing the math. Basically, you can actually reduce this by 90%. My advice is don't go directly to that level of sampling. The way it is done is every week sample out small sets of data, see how it works, and then go ahead with this over a period of 1 month. Yeah. Yes.
Can we also apply this to logging? Because logging is where a lot of data goes into the storage.
Yes, absolutely. Logging, you can definitely do a lot of things. You can again drop a lot of logs, example debug logs, or you could drop certain health check log lines. You could drop log lines based on something which is not required. You could drop those. Sampling of log lines is something which I'm not sure if that would work as expected, but as in sampling is something which typically you drop the log lines which are not required. But if there are some successful log lines, it's very difficult to decide it's a success or not. The only thing is the severity. Is it a warning, info? You might need them. So that's how sampling in logs works. In fact, my demo is going to cover that. Yeah. The edge filtering. So this is the answer to the question on where do you stop this data? Where do you drop it? So there are actually multiple layers here. So from the application side, you stop writing metrics to the application side. Okay. The other is the hotel collector or an agent. Okay, there is an agent which takes your telemetry data and sends it to an observability platform. You could actually apply it there as well. Okay, these are the two places you should apply for max benefit. But sometimes you can actually try to drop them at the backend. Backend here is the observability platform. You can decide to do it pre-ingestion as well. Okay, so there are different things based on where you drop. There is a money associated with it. Okay, now should you drop it at the source, as in drop it at the source is the recommendation, but should you really drop it at the ingestion, so developer level? So how many of you are developers here? Okay, very few, right? So others are DevOps. So the DevOps engineers are going to agree with me. Anything you ask the developers, make this change, they will never do it. Okay, so let's not go to the devs. Let's do it at the hotel collector side. We are all SREs. So we can have more control over them. Let developers write whatever garbage they want to. We will control the cost at the hotel side. So that is the collector side. So that is the recommendation. And how do you do that? And that is exactly the control that you have as an SRE, which you should be exploring out. Okay. The other thing which is not covered in the session, but at the query time, how optimal queries you write is also going to cost you. So if you're going to query this is especially true for an in-house observability platform if you're building, the kind of queries you're going to run is going to cost you compute units. So can you optimize those? Can you do pre-aggregations so that your queries are also going to be cheaper? Okay, so this is just what I said. Do it at the collector side. The edge filtering, do it at the collector side, most recommended. There are also some observability platforms who might give it at pre-ingestion or post-ingestion also, so you can explore that as well. Okay, this is again an example of how you would do edge filtering at the collector side, the hotel collector. I'll be sharing this presentation. So just getting this all together, these are the things that we spoke about. There are a lot more ways. Happy to discuss these after the session as well. I'll spend a few minutes in the demo to quickly show. Do we have time for the demo? Maybe a few minutes.
5 more minutes, so we can use it for a demo.
Okay, yeah. Okay, so this is one observability platform. It is Last9 because I work for Last9, but it could be any observability platform. Zoom, yeah. Yeah. So basically, this is showing you the logs. So this is an example of logs, by the way, of what you could do. There are going to be two different ways. I'll quickly show them. So this is actually showing you the logs of a notification service and an order service. You can see different types of logs, debug, info logs getting generated. Okay, if you want to see a trend over time, all that I have done here is, this is actually showing you the count of log lines per severity level. Example, it is telling you at the bottom of the screen, so there are a lot of debug logs rewritten, and there are also some info logs, and there are probably some other logs also written here, maybe errors and warns. There are very less of these. So if you see the trend is that there are a lot of debug logs written, okay? Let us try to drop those, and I'll just show you two different ways by which you could do that. So one is at the application side. So what you could do without actually making changes in the application, but here this is a Spring Boot application, you could say that, okay, I want to just set debug level to info. Okay, so I'll just, okay. So this is my Docker compose file. And what I have done is I'm just going to add line number 153 to 161. This is a typical Spring Boot configuration. Okay, this is at the application side. You have said that just send me info logs and don't send me anything else. This is one way. We'll apply this for an order service here. So this is we'll apply it for notification service. Other place, okay, so there is this hotel collector config for which is running for my order service. Okay, this is actually showcasing two different ways of how you're sending these logs. I'll quickly spend 1 minute on that. In this particular case, the notification service is sending the logs directly to an HTTP endpoint. There's no collector in between. In this case, there is a collector. Okay, this is an hotel collector. And what we are going to tell this is just filter out logs. Yeah. So in this pipeline, I'm just going to tell it that it has to filter logs based on this. Okay, now how would you actually apply this is basically in this particular case, okay. Okay, so if you have made any changes to the application side, you'll have to restart that application, which was notification service. Okay, so note here, we'll be restarting the notification service. It's again another way we should not be doing that, because any changes here, it's involving changes to your application side. But if you want to apply the changes that we did for order collector service, we would have to just restart the hotel collector in that case. And we are not restarting the service. Okay, so basically the advantage again of making changes with the collector is it does not require your application restart. If you make any changes to your application side, even config that I did, it will require changes to your application side. I've just restarted this. I hope it's going to work as expected. And let's see. Okay, so we have just applied those changes, and I think we've stopped getting the debug logs from around 11 o'clock from order service. And yeah, even from both of them, we've actually stopped getting the debug logs from 11 o'clock where we just applied. Let's see this count as well. So while this gets applied and starts showing up here, so if you can see the logs are also getting dropped here.